Hey there, welcome to the video. Today we're diving into a fascinating problem regarding the behavior of three major compilers: GCC, Clang, and MSVC. The problem at hand involves understanding how these compilers handle large integer literals in C++ code and determining whether their behavior aligns with C++ standards. Let's explore this intriguing problem together. Now, let's talk about the solution to the problem we just discussed. When we look at the code snippet provided, we see the declaration of a constant variable in1 initialized with a very large decimal integer literal. The value 922336720368547775807 is 2 to the power of 63 minus 1. According to C++ rules, since this integer literal falls within the range that can be represented by a long type, in1 is correctly identified as a long. Moving on with the solution, we encounter two more constant variables, int2 and int3, initialized with even larger integer literals 922333720368547758008 and 1-844674740973709551615, respectively. These values correspond to 2 to the power of 63 and 2 to the power of 64 minus 1. Here's where things get interesting. Despite the compilers emitting warnings or errors due to these values exceeding the representable range of standard integer types, GCC takes a unique approach in choosing the type, even for int3. To wrap up everything we've discussed, it's clear that the handling of large decimal integer literals by GCC, Clang, and MSVC can differ, especially when dealing with values outside the standard type range. While GCC may exhibit unique behaviors like treating ill-formed code as well-formed, it's crucial to remember the importance of adhering to C++ standards. Understanding these nuances can help us write more robust and compliant code. Thanks for watching, and remember to like, subscribe, and comment below with your thoughts.